So in this video, I'm going to do one more optimization example from the packet. It's number 5 and it's on page 23. So a garden has 200 pounds of watermelon growing in it. Every day, the total watermelons increase by 5 pounds. And at the same time, the price per pound of watermelon goes down by 0.01 cents. If the current price is 90 cents per pound, how much longer should the watermelon grow in order to fetch the highest price possible? So we want the highest price, which is maximum. And again, we'll just call our price our revenue. So we are trying to maximize our revenue. And revenue in this case, it's kind of similar to the strawberries. How we get our revenue is we're talking about the pounds of watermelon and how much they cost. And so we would take the number of pounds of watermelon and we would multiply it by the price per pound. And that would give us our total revenue, our total, the total amount we could charge for our watermelon. So our idea is to figure out how much longer should the watermelon grow. So we are going to let X be our number of days after our starting point. And our starting point is that our watermelon is 200 pounds. Since we have 200 pounds, or you can write watermelon is 200 pounds, something like that. But you want to define your X value. And then we are going to write two expressions, one for the number of pounds and one for the price per pound based on what they told us. So for the number of pounds, we're starting with 200 pounds, and every day the total amount of watermelons increased by 5 pounds. So we would start with 200, and again, X is our number of days since 200 pounds. So we would multiply 5 by however many days after the starting point, and then add it to 200, and that would give us the total number of pounds. Now the price per pound has to do with the dollar amount. So it says the current price is 90 cents per pound, so that's what we're starting with. And it says it goes down by 1 cent. And that's, again, it goes down by 1 cent for every day after these 200 pounds. So we would subtract 0.01 times however many days after our 200 pounds. So this is my expression for revenue. You can either multiply it out or do product rule to find the derivative. And since the other ones I've multiplied out, I'll just do product rule for this one when I'm doing the derivative. So before I do that, I'm going to define my two pieces. So this is my F and this is my G. And then I'm going to take the derivative of both of them. So the derivative of 200 plus 5x is just 5, because 200 is 0 and 5x is 5. The derivative of g, 0.90, negative 0.01x is negative 0.01. And then when I do product rule, I multiply f times g prime and then f prime times g. It doesn't really matter which one you start with, if you start with f or f prime, but just make sure that if you start with f, then you're multiplying it by g prime. And if you start with f prime, you're multiplying it by g. I usually start with f, but again, you can do either order. So I'm going to do f times g prime plus, like, remember our product rule, I write it out in symbols, f times g prime plus g times f prime. So I have 0.90 minus 0.01x times 5. Now, because I need to find where I prime of x equals 0 to figure out where our max is, I do have to now distribute and simplify. So probably distributing initially is faster, or doing FOIL initially, but I just wanted to show you a different way you could do it. So I'm going to multiply this negative 0.01 times 200 and times 5x. So I get negative 2 plus, and then 5x times negative 0.01, which sorry, it should be minus or plus a negative 0.05x. And then I'm going to multiply this 5 by the 0.90 and the 0.01x. So times 0.90 times 5 is going to be plus a 4.5. And then negative 0.01x times 5 is a negative 0.05x. I'm going to combine my like terms. So I get negative 2 plus 4.5, which is 2.5. And I have negative 0.05x and negative 0.05x, which is negative 0.10x. I'm going to set this equal to 0. So I'm going to add the 0.10 to the other side and then divide by the 0.10. So I'm going to do 2.5 divided by 0.10, and I get x equals 25. Okay. And again, remember what we're talking about. X is the number of days since 200 pounds. So we're saying it's 25 days since the watermelons were at 200 pounds. And let's just make sure, what is everything they ask us for? How much longer should the watermelon grow? So we answered that. The only thing we didn't do is verify that it's a max. So we need to make sure that it's a max. So to do that, I'm going to take the second derivative. So this is my first derivative here. My second derivative would be negative 0.10. So it's concave down, and I have a max at the critical point of x equals 25. Okay, so that's the last example I plan to do on optimization. And if you need help with it, just let me know.